Good day. This is Mr. Stole from Emerson Gravitas, as you can see on the paper there. Now, what we're going to do today is trig graphs. Now, we have two graphs here, like y is equal to sine theta, y is equal to cos theta, and these two have got, both of them have got an amplitude of 1. So here, from x-axis to the maximum point, it's actually 1. For both of them, it's actually 1. So then the range is from -1 to +1. That's what we mean, range in terms of y-axis. This is from -1 to +1. Then maximum value is your 1, minimum value is -1. So always you must know that your cos and your sine can only give you what call values below 1. Okay. Then, but when you look at tan have got amplitude is infinity. So what we have here is that the range is its element of your numbers, meaning to say it's from -infinity down here to +infinity. It doesn't have a maximum value, the tan. Then that's why you can say arctan of even 25. You can even say arctan shift tan 25. You can still get a value, okay, angle of 87. Now, but you can't do that with sine. You can't do that with sine. If you have to say arc sine of, let's say 2, you can't have that. It's gonna give you error. You can't get that. Now, asymptotes now. So your tan, you've got asymptote, so it doesn't touch some of the values. So like 90 is an asymptote, 270 is also what an asymptote for tan. It goes on also on the negative side. It's going to be -90, -270. It doesn't give you any value. So you must know it doesn't touch the 90 and actually 270. So this is what you need to understand here. When you see that it's 0 and 0, so when you say sine 0, it's going to give you 0, but when you say cos 0, it's going to give you 1. That's what you mean by this graph. Then if you say sine 180, tan 180 is going to give you -1. Then if you say sine 90, it's going to give you 1. That's what it means here. Then here now we have got from the general solution, I think now you understand that you can get tan is positive in the first quadrant, in the third quadrant. So you see that in the first quadrant 45, then if you say 180 plus 45, you have 225, and it's still giving the same value, which is 1. Okay, so that's what we have with the general graphs. Now let's now look on the sketching of graphs. Now we want to introduce, now that was normal graph of sine, but now what if we bring in A and Q? So what are the effects of these two? So A sine X plus Q, they have the same effect here. So A affects what? The steepness. So I will show you. So it actually stretches the graph. Then also it affects the amplitude. So it stretches and also affects the what called the amplitude. Then if A is less than 0, meaning to say it's negative, it means that the graph will be reflected in the x-axis. Okay. Then, but there is no effect on the period. There is no effect on the period. Now, on the period, you have to understand that the period for sine and cos is 360. The period for tan is 180. Okay, that's what we know. Now let's look at y is equals to 2 sine x. Now let's try to draw it. We're going to sketch with you here. Now we have got, I'm going to draw this. Now what you need to understand, when you're sketching, you've got major intervals. You've got major intervals of 0, 90, 180, 270, and 360. These are the intervals that you must always worry about. These are the major intervals. What they give you 0, 1, 0, 1. It goes on like that. It depends on the graph. If it's is it sine or is it cos? Okay. Now what we know here is that when sine is when we say sine 0, we're just gonna get 0 here because sine 0 is 0. But now what about when we say tan sine 90, sine 90, let's check here. If we say sine 90, it must give us 1. But we're going to say 1 times 2, we get 2. So it means that instead of having amplitude of 1 is now having an amplitude of what? Of 2. So we are saying the maximum value now becomes 2. Then what about down here? It's gonna be 1. If it is 180, sine 180 is what? 0, and it's gonna give you 0. Even if we put 2 times 0, it's gonna give you 0. What about sine 270? It's giving you -1. Now, when it's -1, we say -1 times the 2 here that we have here. What will we get? We'll get -2. So we have -1 and -2. So instead of our graph reaching maximum of 1, we're now reaching maximum of 2. So we'll draw a graph. It goes like this. Comes back, goes -2, then it comes back to 2. So can you see that what we're having? We are actually stretching our graph. We're actually stretching our graph, where the normal graph must come to 1, okay? Then it goes down to 180, then it goes down to -1, then it goes on to 3 skis. That's what a normal graph should be. Now, the mother graph. Now, that's what we have here. So you must know that now we've got 90 and 2. So our amplitude now have changed because of the A in this case. Then here what we have got 270 and -2. That's what we are having now. Okay, now let's move on to y is equals to negative cos x. Now, can you see what we have here? We have a negative here. Negative, what does negative tell us? It's a reflection in the x-axis. Now let's draw our graph. Then what do we have there? This is graph of cos. We want to draw a graph of cos. Now we have got 0. Remember 90. Our intervals 180, 270, and 360. These are our intervals. Okay, these are our intervals. Now, what do we have with our intervals? But now, what do we know is a reflection now. So, what is it that we're supposed to get here? If we say cos 0, we get 1. So times -1 is going to give you -1. So we have got -1 here. So it's starting here. That's our first point. Then if we say sine 90 is going to give us 0, cos 90 is going to give us 0. So 1 negative times 0 is going to give us 0. Then we've got our 1 there. What about 180? If we say 180, it's going to give us -1. -1 times -1, we get +1. That's why we are having a maximum here. Then here, what do we have? We have our, it's going to come to 0. Then we have our minimum of -1 here. So our graph now will look like this now. We'll sketch our graph like this. It's going to touch maximum, then it comes back. Okay. Now, another thing when you're sketching, don't repeat, don't like this. Don't do that. Pass once. You must draw a smooth curve. You must learn to draw what you call a smooth curve. So can we see what we have here? Our normal graph should be starting from 1, negative comes here to 180, comes there, then it comes there. That's what should be our mother graph should look like. Graph of course x, but because of the negative, can you see what we're having is now a reflection in the x-axis, reflected in the x-axis. Okay, that's what we are having there. So you must always remember that when it's negative, you reflect it. Then you also look into other things like if there are 2, which affects also your amplitude. Okay, now let's move on to the q, effects of q. Now, here, the effect of Q here, remember we say it is a vertical shift. It's a vertical shift. It's a vertical shift. Now, when we say +3, we are not going to be worried about the negative part. So we'll make the negative part small. Then we don't have much. We're not going to work with the negative part here. So we don't have to stretch it much. Now, then we have, what do we have here? We have got 3. Now, when we say +3 now, we are shifting the whole graph by 3 units. Now, what I encourage you to do, you go to 3, you write your 3 there. When you write your 3, that becomes your reference line. Now, meaning to say, it becomes your, it acts as your x-axis, new x-axis now. It acts as your new x-axis. But remember what we have here, intervals of 90, 180, 270, and 360. Now, with these intervals, we are now going to know that we know that the amplitude didn't change here. So what is the amplitude? We're going to the next figure. There is 4. Then below it is 2. Then we've got 1 here. Sorry, I'm putting -2 there instead of 2. Okay. Now, what do we have here is 2. Okay. Then we've got 1. Now, we know that when we say sine 0, we get 0. Then we say 0 plus 3, we get what? We get 3. That's why we are at 3 there. That's why we are at 3. Then when we say sine 90, we get 1. Sine 90, we get 1 plus 3, we get 4. That's why we have to go to 4 now at 90. It has to align here. It has to align. You don't need to write your 90 here on top. Then what do we have on top? What called bottom here? We know that it's going to cut. It's going to cut at 180. Then it's going to be at 270. Then it's going to be at at 360. That becomes the new 0. Now, what do we have? Our graph now, our new graph now. Our new graph will look like this. We start there. We come down here. We have to come to 2. Then go to 3. 360. That's our new graph now. Then the normal graph should have been look like this. But what have we done? We have shifted the graph. So when you see the figure here, before you do anything, don't worry, just go to that number and make a reference line. Then from there, you start to see if there was 2 here, we know that we're going to say 2 units up, we're going to reach 5. Now, let's move on to tan x plus 1. Tan x plus 1. Tan x plus 1. Then let's see what we're going to have there. Again, what do I encourage you to do? We write our intervals: 90, 180, 270, and 360. That's our major intervals. Now we have got 0 there. Now, what do we have now? We know that this is an asymptote. This is an asymptote. So here with our tan there, what do we have? We have got 1. We are saying it's shifting by 1 unit. Now your new reference line again becomes what? Becomes 1. Becomes your 1. Remember what we said? It becomes your new reference line. Now when you're at 1, what do we know? We know that your tan doesn't touch the graph. Doesn't touch the graph doesn't touch the graph on this line, and doesn't also touch the graph here on the 270. Doesn't your line doesn't touch this line, it doesn't touch the asymptote. We call this the asymptote. These lines, we call them the asymptotes. Okay. Now let's see here our tan graph. This becomes our 0, where tan 0 is. It becomes our 0 here. Now what do we have? It's gonna come like this, comes to what? To 1. So it means that this becomes our new 0 there. Now then from there, let's have our tan again. We know that our tan, what is it's used to do? This is what touch here at what? At 180. And at 180, can we see what we are having? We are having it at 1. Okay, it's aligning at 1. Then here it has to touch the graph below 180. So this should be 135. So 135. Then there it goes on up. It goes up like that. Now, why 135? Because here we know that 135 is give us -1. 135 gives us -1. And we say tan 135 plus 1, we get 0. That's why we are putting it here at 0 there. Then the other graph here, because it's gonna turn from what? 360. It's a align at 360. Okay, you don't have to put it on the x-axis at 360. It has to be below 360. It has to be below 360. And this below 360, how do we get that? How do we get these values? we have to say 360 to find the angle minus 45, we get 315. So it's touching this graph here at what? 315. 315. So if you say tan 315, tan 315 plus 1, you get 0. That's why we are touching, it's touching at what? At 315 here, because it gives us a negative. It gives us negative. So this is how your graph will look like, because we have shifted the graph by how many units? By 1 unit. Now let's check here the normal graph, what it should be look like. It should look like this. Okay, it should look like this, touching at 180. Okay, it's 180 and going down like that. That's what it should be. And here it should start from 360 going down. That's what the normal graph should look like. But here, because we have shifted the graph, we need to worry now. We need to actually use our one as our reference x-axis. Okay, new x-axis. Now let's move on to the last 2 questions that we have here. If it is 3 sine x plus 4. Now it's a bit tricky here, because we are shifting our graph 2 units up, 4 units up. And if I just shift 4 units up, what did I say, guys? Then let's have the graph here. We are going to have 0, 90, 180, 270, and 360. Now, with these values now, we know that our 4, let's put 1, 2, 3, 4, and let's say 5, 6, 7. We're gonna need that up to 7. Now, what do we have here? We are at 4 now. Our 4 becomes our reference line. Simple as that. Becomes our reference line. Now, when we have our 4 as our reference line, what do we have? We are going to say now, and we now have 3. Now, sine 0 is going to be what? Sine 0 is going to be 4, because sine 0 is going to be 3, sine 0, 0, then plus 4, we get 4. That's why we are starting at 4. Then from there, we have to say, now, when it's sine 90, where it's 90, it's supposed to be 1. So you say 3 sine 90 plus 4, we get what? We get 7. 3 sine 90 plus 4, we get 7. Why are we getting 7? Because remember, it's changing the amplitude. The amplitude now is 3. So 3 units from 4 is actually giving us 7. So we know that it's going to be, it has to align with 90. It has to align down with 90. Then it has to cut the graph at 180. It has to also be how many units down? 3 units. So if 3 units, it reaches 1. So it needs to be a 270. It needs to be giving you 1. Then at 360, it's going to give you 4. So let's start here. We're going to go like this. It's going to touch there, sorry. Then come down at 4 to 1. Then it comes back to what is it? To 4. To what's equal to 4. So you can see that it's aligning with 360. It's aligning also with 90, and here it's aligning with 80. It's aligning with 270. This is what you need always to remember, guys, that you are shifting your graph. When you shift your graph, whatever Q is becomes your reference point, and you won't have much problem with that. Now, let's look at tan. Now, let's check here. Remember what I said here. A, because it's not negative here, we're not going to worry about the reflection part. But now, because it's half, what are we going to be worried about? Steepness. We are going to be worried about steepness. So this is half from 1. It means that this one is less steep than tan normal graph of tan x. It's less steep. So what do we expect here? We expect it to be what you call not to be, what is it? So we have got here, we can see that the curve now, it should be like this. It won't be steep going there. And this side also, it won't be, what is it? It won't be steep. It won't be steep. I'm going to show you what I mean here. Now, let's see the other one, the last part there. Now, the normal graph now of tan x is bit steep. It's bit because they've got gradient of 1. It's a gradient of 1 here. So what do we have here? It's gonna be like this. So when we have got a 2, whatever a is, as long as it's not negative, you are not going to be worried. You're just going to draw a normal graph of what? A normal graph of tan, unless specify that you need to draw maybe graph of tan x and the graph of half x on the same axis. Then in that case, you have to show the difference in steepness. But here is what we have here. Can you see what we have? This one is a bit steeper. It's a bit steeper here. That's what we're going to have there. So this is what we have. And here is also a bit steeper going down there. Okay, so that's what we need to worry about when it comes to tan. Tan, as long as it's not negative, you don't need to worry about reflection. But here in this case is what is just a number. And when it's a number, just worry about the steepness. And it stresses when you're only drawing 2 of them. Like in this case, if they are to draw tan x and half tan x. Okay, so guys, until next time, I hope you guys understand. Thank you so much.